Okay, I think we're live.
All right.
Well, how have you been?
Uh, I'm not entirely sure how to answer that.
It's all right. Well, hopefully today's session goes a little better than last time. I think I feel more prepared going into it, but
Yeah,
we'll
I
see
do.
how it goes.
There's still just a few things on this chapter that I'm still like, I don't really quite get.
Yeah, his videos explain it pretty well, and I think he covers everything he would ask us in his videos. So I think that's for the future, I'm probably going to focus on those when I'm preparing because
Yeah, I watched the videos
well,
earlier today. I I was honestly it was kind of hard to follow them just
okay.
because I was just like, this is so boring.
Yeah. I've taken a class really similar to this before, and so I'm mostly remembering things.
Yeah,
So it's not like learning for the first time. This would be a lot harder if it was the first time for me, I think, but
yeah.
yeah, I took math. Is this is this class 109 or 111?
It's 111.
Right? Yeah, so I took 110, and so far it's fairly similar. Different
Yeah,
format, but similar content. So,
yeah.
well, I guess let's go ahead and um, yeah, let's have our team discussion.
Okay.
So, make sure each team member filled out the table properly from the prep activities. Whoops. Um, oh, okay. Okay. So the table was the inverse of everything, the sine or arc sine of x, and showing the range of each one.
Yeah.
I guess there's two tables here. Okay. Did you do that?
Yeah,
I,
kind of.
I didn't really do the table exactly, but I know what it's asking, and I have notes a little bit differently using
Yeah.
like the which part of the circle that the cosine and secant are in, and then the sine and cosecant. And
Yeah.
so I guess sine of negative or inverse sine of x, the range of that is going to be the domain of sine of x,
Yeah.
correct?
Yeah.
So basically, the domain of sine of x is pi over 2, or negative pi over 2 to pi over 2.
Yeah.
Yeah. So as long as you don't get your head twisted around there, I don't think that's too bad.
Yeah.
Um, yeah, so I guess for that, I guess it's important to note that cosine and secant are the same. And then, like, those are what is that? The negative pi over 2 to pi over 2. Wait, is that right? Let me think about that. No, no, no. Cosine and secant are 0 to pi. I need to write that down. And then sine, cosecant, tangent, and cotangent are negative pi over 2 to pi over 2. And then if it's the inverse, then you just swap. So those are the domains that I'm looking at right now.
Oh, okay.
Sorry, yeah, I should have said that before elaborating on.
I was like, he's throwing out a lot of stuff, and I'm not seeing what he's talking about.
Sorry. All right. Well, I think we're pretty clear on that table then, right? Do you
Yeah,
have
yeah, I
any
think so.
questions about that? So far, so good. Okay. Let's see. Discuss the solution and methods for answering question number 5 from the prep activities. So let's go to that one. Okay, so that's the triangle
Yeah.
with the 42-degree angle. All right, I'm just gonna write it down and we can start doing this.
Okay.
I didn't do the practice questions. I got through most of the lesson
Yeah.
and we'll go from there. I'm feeling relatively confident with this though. So the question is, use the fact that the sum of the angles of a triangle add up to 180 degrees to solve for the missing angle. Then you can use trigonometric functions to solve for the missing sides.
Okay.
So
So right,
what's to solve for the angle?
yeah, we
Oh,
need a alpha. Or wait, is that what is that?
um,
I think that's
I
alpha.
think that's alpha, right?
Yeah.
Yeah, that's alpha.
Mhm. Basically, you
Um,
take the 90% minus the 42%.
yeah, degrees, yeah.
Or right, not percent.
Yes. Yeah, so you've got the 90 used up. Yeah, so I guess the proper way is 180 minus the 90 degrees minus the 42 degrees leaves us with 48 degrees for alpha.
Yep.
So alpha equals 48 degrees. Okay, I think we're clear on that, right?
Yeah.
And then the missing sides. So we have that opposite side that is 7.
Mm-hmm.
So I guess let's solve for C first. There's a few different ways we can do that, but actually, let's solve for A first.
All right.
No, actually, I was thinking it was a 45, 45, 90 just by looking at it. It's not. Yeah, do you want to do A or C first?
Uh, I'm fine with A.
Okay, let's do A. So that would be tangent of 42 degrees, correct?
I think so. Wait. Why
Oh,
would we use tangent?
if you use the 42 degrees, then you need to use the opposite over adjacent, right?
Um, okay. Okay. Yeah. Yeah. Yeah.
Or you could use the alpha that we just found and use sine if you wanted to, but
Oh, okay. Yeah, that
both
makes
ways
sense.
work.
Okay. So 7 over tangent 42 degrees.
Um, that sounds about right. Let me think about that. So tangent of 42 degrees equals 7 over A. Yeah. Yeah, so 7 divided by tangent of 42. I got 7.77.
Okay.
Is that what you got?
Yeah.
Okay. And then for C, we can do sine of 42. Which I got 10.46.
Yep.
Okay. All right, I think that's pretty straightforward for me. Do you have questions about that?
I don't think so.
Okay.
Uh, so let's see. So if we wanted to find C, we would use sine, and that would be the opposite over adjacent.
Opposite over hypotenuse, because the hypotenuse is always the longest side.
All right. Opposite
Yeah.
over hypotenuse for sine.
Yeah, so SOHCAHTOA, right?
Mm-hmm.
Sine is opposite over hypotenuse. Uh, cosine is ca, or adjacent over hypotenuse. And tangent, toa, opposite
Opposite.
over adjacent.
Okay. Right. Now it's starting to come back.
Yeah. Okay. Anything else there?
No, I think I'm good there.
Okay, what's next? I think that's it for the discussion. Let's do a couple extension problems here. I didn't figure out how to do the triangle inside of the triangle thing yet. I might need to watch the video on that. Um, so yeah, looking at the extension problems, I think we could do the first one together, I guess.
Okay. Where are the extension problems?
So on the instructions for GHOA page, the Google Hangouts on Air,
Oh,
Goa, I don't know what to call that.
I was just looking at the preparation stuff.
Oh yeah.
Okay.
All right, so tangent of pi over 6 is the first one. If we use our unit triangle, we can find pi or 5 pi over 6. Sorry, I said that wrong.
Yeah. So
5 pi over 6 is 150 degrees, right?
yeah.
And then tangent is, if we go back to our other references, tangent is sine over cosine.
Yeah. So sine over cosine. Bam.
So sine is the y coordinate, cosine is the x coordinate.
Yeah.
And so we can just do the 1/2 divided by
So it would be negative
over 2.
square root of 3 over 3.
Three, which equals. Yep, I agree.
Okay, cool.
I hope that's all correct. I guess we can look at the key, but let's do the sine, inverse sine of negative 1/2.
Okay. So,
That one seems confusing.
um, I think
Inverse.
it's pi over 6 or negative pi over 6. Wait, yeah, I think it's
Negative pi
negative
over
pi
6.
over 6. That's what I think it
Okay.
is.
That seems like that would be my guess as well, I think. I'm gonna write it down and we can check it. Yeah, so I guess you just do the reverse thing and find negative 1/2 on the sine coordinate, which is y on your unit circle, and then convert that back.
Yeah.
Okay. I'm going to open up the key just so that we can find out whether we're right or wrong before we assume we're right. Okay, yep, we are correct on both of those so far. So that's
Okay.
good. Okay, do you know how to do that second one, the cosine of inverse tangent question?
Uh,
Because I
hmm.
don't,
Let's.
unless
Okay.
unless it's how I think it is, and you just figure out the inside one and then use that value to figure out the
Yeah.
outside?
Yeah, that's what you do. The only thing that I'm kind of confused on is wait, no, hold on. That'd be square root of 3 over 3, but I don't
Yeah,
see a.
so root 3 over 3 is not on the unit circle.
Wait, then how are we supposed to find that?
I don't know.
See, it's problems like that where I'm just like, I don't understand this. They throw
Yeah,
stuff on there that's not even on the unit circle.
yeah, agreed. Yeah, all of the other ones are on the unit circle too. That's the only one that's not.
Okay, hold on. So, unless we thought of it as sine over cosine, then,
There's sine over cosine.
but that still doesn't seem right.
Yeah.
Wait a second. So it's 1 over square root of 3. Unless. Wait, I think I might have something.
Okay.
So, if we think of it like how it got to that, how it got to 1 over square root of 3, because
Mm-hmm.
for one thing, you can't have a square root in the denominator at all.
Mm-hmm.
So, if you try and like work backwards, so if we have 1 over square root of 3, what combinations can make that?
That's
So,
true.
so what I'm thinking is I that would have to be the cosine would have to be square root of 3 over 2, and the sine would have to be 1 over 2.
Okay.
So if that's the case, then on the unit circle, the only one that matches up would be the point of pi over 6.
Okay. I can agree with
The
that.
the only thing that's tripping me up now is I can't really remember what if that's the inverse itself, the in or arc tangent or whatever,
Yeah.
or it would be over. Actually, wait.
No,
Wasn't there something?
it would be the arctangent because when you do it reversed like that, you have a number that turns into a radian
Okay.
value, right? So we have the number given there, and it would turn into pi over 6 or pi over something, or.
Okay.
So I think that's correct because if we do it the opposite way, like in the first question where it's tangent of 5 pi over 6, like we use that to get a number that doesn't involve pi at all.
Yeah. Okay.
It's not a radian anymore.
All right.
So
So
I think that's correct. I think it is pi over 6.
okay.
So yeah, that was great actually. That's going to be tricky on the test for sure, unless we
Yeah.
can figure out how to work backward on all of them. But I think they're all going to be relating to root 2 or root 3 only.
Okay. So in that case,
Um,
if that equals out to just pi over 6,
yeah, then
then
cosine of pi over 6
would
would
just be
be
square root of 3 over 2.
root 3 over 2.
And just looking at the key now, that is the answer.
Sweet. All right, cool. Well, we're on to something then.
Whew.
All right. Well, do we want to do a challenge one and figure out what in the world that last one's going to be? That cosecant, arc cosecant cotangent of 5 pi over 4? Just to make sure we got this.
Yeah, okay. So remind me what cotangent is. Like what makes up cotangent?
It's just the inverse of tangent. So
Okay, so it'd
tangent
be
is sine
cosine
over
over sine?
cosine, so it's probably cosine over sine,
Okay.
which
So
is, yeah.
okay, so on the unit circle, 5 pi over 4 is negative square root 2 over 2 negative square root 2 over 2.
Which is,
So that would just be 1.
mm-hmm.
Okay,
So
so
inverse cosecant of 1.
oh jeez.
uh,
Wait, there's not even oh wait, no, there is kind of a 1 on the unit circle. So ha ha ha.
so first off, cosecant must be or inverse cosecant must be in the domain 0 to pi, which
Okay.
that's not. I'm confused how that works. One.
So so the inverse uh of cosecant is just 0 to pi.
Is it just pi?
I I don't think it's quite that easy, but you said the range of that is just from 0 to pi for cos
Yeah.
the okay.
Or the domain. Hang on, let me
Oh,
think about this. Yeah. Ugh, all right, I'm getting all sorts of confused now. Inverse cosecant. Can you do that on a calculator? I don't know if I can. Dang.
Can you remember what arc cosecant is made up of?
Um, Not really.
Okay.
I mean, cosecant is cosine over sine, but other than that, I don't. Ugh. Hang on. Oh, okay. In his video, it looks like there might be. Okay, so inverse cosecant is equal to. I'll write it out. Actually, it's going to be hard to explain without me showing you on paper.
Okay. I'll be right back.
Sure. Okay. So this is one thing that he does show. Is that reversed on your screen?
I don't think so. The words aren't backwards.
Okay, it's backwards on mine. Anyways, so cosecant or inverse cosecant of x equals inverse of sine of 1 over x. Do you see that?
Yeah.
So I think we can just maybe do the math that way and it'll be easier.
Yeah. Okay. So we said that we got to the point where it was inverse cosecant of 1. So that'd be the same thing as uh wait.
Should be the same thing as arc sine of 1 over 1,
Yeah.
which is still 1.
Yeah. So if we went to 1 of, wait, would it be the, would it
So
be
pi over
the,
2.
oh, so it would be the y then?
Yeah.
Okay. I was just wondering if we had to do the x or the y for that.
Yeah, so sine is always the y coordinate. Cosine is always the x coordinate.
Oh. Yeah, I guess that does make sense. I was still thinking of like cosecant. I was like, what do we do for that?
Oh, yeah.
But no, that does make sense, even if it is arc sine.
I think that works, right? Should be, let's look at the key. Pi over 2. Sweet.
All right.
Yeah, that's right.
So,
Okay, so just because this looks weird, the fourth question there, the cotangent of 9 pi, on the answer key it says the answer is undefined. But why? I gotta think of it. Oh, because
it's
the
probably
0 is
divided.
yeah, divided by 0. Okay, never mind. That makes sense. Okay. All right. Well, let's do problem 2 on the Goa assignment.
Okay.
So, given the following triangles, solve for the unknown pieces. All right. Well, let's. Do you want to do one of them and I'll do the other one or something?
Sure.
Okay. Well, do you want the easy one or the hard one? I'm good either way.
Yeah, it doesn't really matter to me.
I'll do the hard one on this one on the right.
Okay.
All right.
All right.
No, the echo.
echo.
Gosh dang
Gosh
it.
dang it.
My
wife's
computer died at like
died at
70%
like
battery.
battery.
So that makes sense.
That makes sense.
Every time
Every time
I get cut off, there's
cut
a
off, there's a
ridiculous echo, and I
echo,
can't
and I
even
can't
talk to you.
Yeah. Sorry about that.
Close your log.
Change it.
You can close
It
it.
doesn't. It doesn't on my
Doesn't
computer.
on my computer.
That's stupid.
It's fine.
It's fine.
All right.
All right.
I'm done with
I'm
mine.
done with mine.
I'm kind of tripped up on mine a little bit.
Okay.
Okay.
I don't know how I'm supposed to solve for the degrees.
Okay. Yeah,
Okay,
that's where
that's
the sine,
the
cosine,
sine,
tangent
cosine
stuff comes in.
comes in.
So
So
you
you
don't have
don't
beta
have
or alpha,
beta,
but you do
alpha,
have the negative angle,
Uh-huh.
which means that you
which
can use
means
the Pythagorean theorem
Pythagorean
right,
theorem
to get your
to
other
get
side.
your other side.
Yeah, I already got the other side.
Okay.
Okay.
I just don't know how to get the degrees for the
Okay.
Okay.
Yeah. So
So
do you want to do it?
do you want to do it?
A or
A
alpha or beta
alpha or
first?
beta first?
let's do alpha.
Okay. So
Okay, so
alpha,
alpha.
you can use
can use
anything since you have
since
all
you
of
have
the
all of the
sides. You can use sine, cosine, or tangent to find that angle.
that angle.
You'll just use
You'll
different
just use
sides
different
depending
sides
on which one
depending
you
on which
choose.
one
So
you choose. So
sine is,
sine is
the most
the
generic
most
one
generic.
people usually use first.
Use first.
Try this.
But
But
it's not really done. It's fine. So sine,
so sine
is opposite over hypotenuse, right?
right?
Yeah.
So
So
6 is your opposite
is your
side.
opposite side.
15 is your
is your
hypotenuse side.
hypotenuse side.
And that gives you
And
your
that gives you
sine.
your sine.
In a
In a
calculator,
calculator,
I think you
I
would
think you
end up
would
doing
end up doing
the inverse
the
sine
inverse sine
of
of
your
your
opposite over hypotenuse.
opposite over
And that would get
hypotenuse.
your value that you're
Value
looking
that you're
for the
looking
angle.
for.
Oh. Yeah.
So
So
alpha
alpha
should be 23.58 degrees.
degrees.
Yeah.
Does that make
Does that
sense?
make sense?
Yeah. That's what I got too. But what I don't get is why do the inverse sign on my calculator?
Because you use sine to go in the
to
forwards
forwards
direction, and then you use
and then you
inverse
use
sine to go
inverse
in the
sine to
other
go in the other
direction. I don't know. That's how he explained it in the video as well.
All right.
Yeah. So if you're going from an angle to a side, you'll use sine. If you're going from sides to an angle, you'll use the inverse.
Oh. Okay. Huh. Alrighty. So then.
Yeah, and then your beta angle
your beta
is
angle
the exact same. You can use inverse sine, inverse cosine, inverse tangent, and then just use the respective angles or sides.
Okay.
Hopefully that is not too confusing. Yeah. So like we used the 6 and the 15 side, but we could have used that B side as well. I didn't calculate what that one was. Do you have any questions there?
No.
Okay.
Let's see here. I'm just like trying to get the last one correct.
Okay.
Okay. Yeah, so beta is 66.42.
Yeah. And so you could do that. Since you already have two of the angles, you can just do the 180 minus the 90 minus your alpha and get that angle. Or you could just do the trig stuff,
Okay.
the inverse sine.
Got it.
All right. Well, we move on. Or should we just try to go for the quiz?
I'd be down for the quiz.
Yeah, I'd rather be fast. So my question number one in the quiz came in wrong. Like it says left processing error in parentheses. And so I can't even see what those are. I'm wondering if yours can, because I'm on a Mac. I don't know why.
So you're saying that you can't get to the group quiz?
No, I'm on the quiz. It just, I'll show you in a picture. I took a picture of it.
Okay.
So question one came in like this.
Oh. That's weird.
Did yours do that?
No, I got it.
Okay, maybe you can read the question then.
Yeah. It's fine too. It's not even that long. So it says, explain why the expected response for arc sine of -1/2 equals negative pi over 6 and not 11 pi over 6.
I'm gonna write the whole thing.
Okay.
Explain why the expected response for arc sine of what?
-1/2.
Okay, what's next?
Arc sine -1/2 equals negative pi over 6 and not 11 pi over 6.
Okay. My answer for that would be because of the constraints that we have to do for the inverse functions.
Yeah. The way that I look at it is every single one of these, like pi over a number, can be told like two different ways depending on which direction you're going.
Yeah. Yeah, it can be. Yeah, I think it just all comes down to the negative and positive, but because they lead to the same spot on the unit circle, it's just the direction that you move to get there. So,
Yeah.
but I would say it has to do with the constraints of the domain. What is it, range? Think about that. I'm confusing myself now.
Or are you getting confused on?
Okay. I wrote my keyzone wrong. These need to all be inverse version, like that table that we talked about at the very beginning today.
Oh, yeah.
Yeah. Okay. That makes more sense. So yeah. So inverse sine will have to be within the constraints of negative pi over 2 to pi over 2.
Okay.
And the 11 pi over 6 is outside of that constraint. So that's my answer to question 1.
Okay. That sounds good.
I'm gonna write that down. Okay. You ready for number 2?
Yep.
Okay. The sun is far enough away that an object and its shadow will make a triangle that is a similar triangle with another object and its shadow. In geometry, we learned that if two shapes are similar, one is an enlargement of the other. This means that the two shapes will have the same angles and their sides will be in the same proportion. What information would be needed to calculate the height of the mathematics building at BYU, Idaho in feet and inches without actually measuring the building? After you list the information needed, set up the problem as if you were going to solve it. Draw and label a picture and set up a ratio. Okay. Okay, does that make sense?
Yeah. So this isn't like one of the triangle within a triangle, is it?
Yes, but they're the same angles.
Oh, okay. So we really don't have to
Yeah,
worry too much about it then.
it's not the hard version of it. It looks like question 3 is the separate angle version that we're gonna have to
Oh.
do.
Okay.
That one's harder.
All right. So.
My answer's pretty fast. Hello. Hey, I'm right now. All right, sorry, Tyler.
So for number 2, I'm not entirely sure what it's asking here. Is it saying, okay, we just need a certain...
So that's a building.
Okay.
And then there's a person down there, and it has the same. It shares the same angle from the sun. So basically, the big triangle that the building makes and its shadow, and the small triangle that the person makes with its shadow are one's just an enlargement of the other one. The angles are all the same, right? But the lengths are different.
Mm-hmm.
So let's see. Yeah, so all the angles are going to be the same, and the sides will have the same proportion, but they won't be the same length.
Okay.
So if you can figure out the distance between the person's feet and his shadow, then you have that bottom angle, or you have that bottom side of the triangle. And then you can just measure from the shadow to the building to get that bottom side. And then you already have all the angles.
Okay.
Or, you can get the angles from the small triangle, and then you know they'll be the same as the angles on the big triangle.
All right.
Yeah,
I was just reading it over. I'm like, okay, so we just need 3 sides and 3 angles. But that doesn't sound right.
Let's see. Like, throw this in a way. Too tiny. How do you draw beta?
Were you asking how to draw beta?
Yeah, I'm just kind of looking it up.
Oh. Yeah, it's just kind of like a capital B, but with a tail.
Yeah. Okay. So it's asking what information would be needed to calculate the height of the mathematics building at BYU, Idaho. So you'd need to know the angle of the person's shadow and the bottom length of the person and also the bottom length. I'm not saying this. So from the shadow to the feet, you'll need that length. And then from the shadow to the building's base. Does that make sense?
Yeah.
So annoying.
I want to forget what I did.
This is really annoying to put into words.
Yeah, I bet.
Okay, so we identified the information. Now set up the following if you were to solve it. Draw and label a picture and set up a ratio. So okay. So if you have the angle at the bottom, and you can get the base length, then your sine are, so sine essentially would be opposite over adjacent. Or sorry, that's not sine. Opposite over adjacent, that's tangent. So you'd want tangent of your angle, right?
Mm-hmm.
And then you'd have the ratio of the building height to the distance from the gate. So tangent. Yeah, this is annoying. Words, for sure. Hang on. Does it want us to use the height of the person to get it? Or can we just use from the base of his feet to the shadow? Hopefully it doesn't matter. I know how to do both. Okay, it doesn't say to actually solve it, so I think we're good there. Let's move on to number 3.
Okay. I actually started working on that since you were doing a lot of the...
Yeah.
A lot of 2.
Good call. All right, I'll read this.
I'll read this.
Try to understand what's going on.
Whoa.
Okay.
All right. I think I might have an answer for number 3,
Okay.
since it's just asking for the height of Rexburg Temple.
Yeah.
I got to about 55.5 feet,
Okay.
but that's just my calculations, and I'm still kind of like weary if that's right or not.
Yeah. Not
But
really sure.
this is kind of the work that I did. If that makes any sense.
Okay. I think what it's asking is. Let me show you my triangle. So it shows us the distance from point X to point Y, which is 75 feet, and it doesn't tell you how far either of those points are from the temple.
Oh, okay. So this is a triangle within a triangle.
Yeah, it is.
Yeah, it is.
Okay, well,
That makes it a lot
It's a
harder.
lot harder.
crap.
I mean,
I mean,
I think there's
I
two
think
ways
there's
to
two ways
solve
to
it.
solve it.
And
And
one of the ways is
the ways is not.
Freak.
Let me look at this. Does it have to be a right triangle to use sine and stuff?
Um, I don't think so.
Okay.
Okay.
Yeah, I don't think it has to be.
Actually, I
Actually, I
think
think
it
it
was.
was.
Oh, really?
I just did a whole bunch of work that doesn't help now that I'm
Now
looking
that
at
I'm
it.
looking at it.
Yeah, we need to
Yeah,
learn
we
how
need
to
to
do
learn
this
how to do
properly.
this properly.
I'm gonna watch this
I'm
video
gonna watch this
really
video
fast.
really fast.
Alright.
He does have
He does have
a video for
a
triangle
video for
and side of
triangle and
triangle, so I'm gonna
So I'm gonna
Yeah.
see if I can
see
figure
if
this
I
out
can
real
figure it
quick.
out.
There's an example
There's
that's
an
exactly
example
the
that's
same, so
exactly
I'm gonna watch this.
Watch this.
Okay.
I never
I
would
never
have
would
guessed
have guessed
how to do
how to
this
do this
without
without
watching the
watching the
video.
video.
Did it make sense to you?
Yeah,
Yeah,
lots of
lots of
algebra.
algebra.
Everything okay over there?
What?
What?
Everything okay over there?
Yeah,
Yeah.
that's, this
This
microphone is really
really
annoying.
annoying.
It's capturing
It's capturing
everything ever since I
since I
lost my
lost
connection
my
or the
connection.
battery died on this
Battery died on
computer.
this computer.
Oh.
Yeah, my wife
Yeah,
is
my
just in
wife
the
is
fridge, but it's
but
really not
it's
even
really
loud.
not even loud.
Oh.
It's just
It's just
amplifying
amplifying
Oh, okay.
everything. Sorry
everything.
about
Sorry
that.
about that.
Oh, that's fine.
Hello everyone. I wanted to show an example of how to solve a triangle inside of another triangle.
Did you find his
Find
video?
this video?
Yeah.
I'm trying to find the height of something.
Okay.
Okay.
So for instance, let's say we have like a hot air balloon right here. It's floating away some distance above the ground. And you know, at some point away, the angle of elevation from the ground up to the hot air balloon point that is 50 feet closer to the blue. So it'll be right there. Angle of elevation, whatever, is 20 feet. So this was 50 feet closer. Now, given this information, I need to now find the height of a triangle. We'll call that y. Now, since the hotter beam is straight above the ground, the height will come down maybe right angle. So I know two angles plus the right angle is 50 feet over here. And I need to somehow find the height of the blue, or in other words, this y value. The way to go about doing this is I use my knowledge of similar triangles. So first piece I'm going to try work with is this triangle right here. I'm going to label this distance x. Now, using my right triangle trick, I can say that the tangent of 1.8 is 5 over x. Now the next triangle I'm going to look at is the big one. The big one's still a right triangle. So now I can say that the tangent has to equal y over, it's going to be the whole distance here. So I know that this is 50, this has to be x, and they have to be together. These two equations, they both share a y. So what I'm going to do is solve both equations for y and equate them. So here I'll have x times tangent 21.8 Notice that
I'm getting such a big headache.
I got a little bit of that myself.
yeah,
Not the best.
times the tangent 21. has to equal 50 plus x tan 90. Now, if you're using different colors, let's recognize where each part of the equation is coming from, particularly in regards to which triangle is coming from. Is that the inside triangle, red, or the outside triangle?
That's my brother opening the soda across the house.
Oh,
You can turn the mic on.
Yeah.
So.
Now, I need to solve this x variable. I've got both sides equations. I need to move all the terms at x onto one side. To do that, I need to multiply this tangent and distribute.
Okay. I got it.
Side
yeah.
axis.
I definitely recommend watching that video because our test is next Saturday. I guarantee we'll have to know how to do that.
Yeah.
For the sake of being done, I'm content with this. I'm confident in the answer.
All right.
I mean, so if you just finish watching the video, you'll understand. Because you do exactly the same thing. Like we use tangents and everything. We just put in different values and do the exact same factoring and set the y's equal to each other. Set it equal to z, and then you have values that you can put into a calculator to put a number, and that gives you the base length, which you can then use with the angle to get the height.
Yeah.
Hopefully that makes sense.
Yeah, totally.
But yeah, I'm confident with this, and I'm ready to turn it in. With that.
All right.
All right. Well, we're good here. So I'll just take a picture of this and send it in, and we'll be good to go.
All right. Sounds good.
Thanks, Tyler. Sorry it took forever.
Nah, it's all good, man. It's just kind of hectic, and
It is.
I'm trying to do better at like getting more prepared for this stuff. But once 3:15 hits, I have a 2-hour and 45-minute lab.
Yeah.
And then I also have that PTOT society, so.
No. I have 10 credits and then I work. And so every single day from 8 to anywhere from 5 to 8 is just full.
Oh, dang.
So then after that, it's time to eat or spend time with my wife, do homework. So,
Yeah.
busy life. It doesn't last forever.
Yeah. Well, cool.
Alrighty, man. I'll let you go.
All right, sounds good. Talk to you later.
Yep. See you, Tyler.
Okay, see ya.